The strategy design pattern is a behavioral design pattern in which an algorithm is decoupled from the client that uses the algorithm. So by decoupling the algorithm from the client, this allows the client to support various different algorithms in order to implement some kind of behavior. So the way this works is that the algorithm is encapsulated behind some kind of strategy interface, and then the client depends on that strategy interface and can take in various different implementations of that interface in order to implement its behavior. So the strategy design pattern is actually pretty common because it supports the ideas of composition over inheritance and decoupling, and in fact I've used it quite a lot on various different projects. So that said, this demo is actually inspired by a project I've worked on in the past. So in this demo we have this dashboard and we want to add items to the dashboard, and then we're just going to write out the dashboard to the console. So let's understand the pieces here. So most importantly, the dashboard. So when we instantiate the dashboard, we give it a width and height, and then with that width and height we create this 2D dashboard items array, and then we can add items to the dashboard. So we can place some kind of number at a dashboard location and then have some validation here. So obviously the X part of the location can't be less than 0 or greater than or equal to the width. Same goes for Y, can't be less than 0 or greater than or equal to the height. And then I only want single digit numbers here. But when we add an item, we just place it in the two-dimensional array for the given X and Y. And then also have this helper function to see if there is an item already at a dashboard location. So with this logic, we're basically saying that if there's a 0 at a location, then that means there's no item there. And then finally, we can convert our dashboard to a string by just iterating over the 2D array, which is what we did when we write it out to the console. So this all makes sense when I run this. In fact, let me put these numbers at different locations and let's see what we get. So as we can see, at x1, y4, we got 1, x2, y4, we got 2, and x3, y4, we got 3. But what happens if I place all of these items at the same location? So let's put all of these at x1, y4, and let's see what we get. So as we can see, we just overwrote the previous items with this last number 3. So 1 and 2, they were placed here before, but they got overwritten. And that's not really the behavior that I want for a dashboard. Instead, what I want to do is if the location we're trying to place at is already taken up, then I want to search for a nearby location that doesn't have an item and then place the item there instead. So for that behavior, I'm actually going to implement a depth first search algorithm. So let's implement our depth first search algorithm function down here. So it's going to return a dashboard location, which is going to be the one that we find from the search, but it could also return null if we couldn't find a location. So we're going to make this optional with a question mark, and we'll call this find available location. We're going to need a start location. So let's get that passed in. And then for a depth first search, you may or may not be familiar with it, but one thing we will need is a hash set of locations that we've already searched. And this just guarantees that we don't search a location more than once and get in some kind of loop where we keep searching the same locations. So we'll just call it searched locations. So the depth first search algorithm is recursive. So we're going to need some base cases in order to get out of the recursive stack. So one of the simplest base cases is if our searched locations hash set already contains the location that we're searching from, then we just want to return early from this function, and we'll just return null, meaning we didn't find a location. But now we're searching at this location, so now we can add our location that we're searching at to that hash set. So other base cases I want to account for is making sure the location that we're searching at is within our 2D array. So kind of implementing this validation logic. So I'm actually going to move this down here. So same kind of logic, except we can just put it all in one if statement. And this is just start location instead of just location. So basically, if the location we're searching at doesn't fit in the 2D array, then it's not a valid location and we're just going to return null. But now that we validated the location, then the location we're searching at could be a location to place the dashboard item. So we're going to check if an item doesn't exist at the location we're searching at. And if there's no item here, then this is a winning location and we can just return that. But now the fun part. So if there already is an item at that start location, then we want to recursively search the locations that surround the location we just checked. So let's get those surrounding locations. So these is going to be an enumerable of dashboard locations. We'll call it surrounding locations and just create that list. And for the surrounding locations, I want the location above the location we just searched. So I can use this handy add method where we just add an X and Y to a location. In this case, the location we just searched. So I want to add 1 to the Y to search above the location. And then we're going to search to the right. So we'll add 1 to the X, 0 to the Y. I want to search to the bottom now, so we'll do -1 for Y. Whoops. And then finally to the left we'll do -1 for X and 0 for Y. And now we can iterate over all of these locations. So let's do a for each, and we'll call this current location, and just iterating over the surrounding locations. And now we can recursively search for available locations from this next location. So let's recursively call find available location. So that'll give us back a dashboard location, available location. And let's recursively call find available location, pass in this current surrounding location, as well as our hash set of already searched locations. And this should be optional because we could return null. And that's actually what we want to check now. So if this available location does not equal null, then that means we successfully found a location and we can just exit out of this. So we can return the available location since we know it actually is a location and it isn't null. And then finally, if we exit this loop and we didn't find an available location, we're just gonna have to return null. So let's do that. So that should sum up our recursive depth first search. Hopefully I don't have any bugs in here. But now let's use this. So we're gonna get a dashboard location back. For the available location, let's find available location, pass in the location that we're trying to place an item at, and let's instantiate that hash set. And of course this could be null, but if we did find a location, so this wasn't null, then let's place an item at that location. So let's take our dashboard items array and specify the X. So let's do value dot X and then value dot Y, and set the number that we want at that location. So now we're still placing these items at the same location, but let's see what we get. All right, so we moved them to new locations. So we moved to the right for 2, and then to the right twice for 3. Although this was surprising because I thought I wanted to search to the top first, and by adding 1, we're actually searching to the bottom first, and we couldn't place them to the bottom because we were already at the last row, so we started going to the right instead. So if I want to start by searching the top, this would have to be -1, so let's do that. So top, and then right, and then I want bottom, so +1, and then left. So this should get us going to the top, which we get. So that looks good, and our depth first search is working. Oh, one sec, getting a phone call. Hello? Yeah, I did the depth first search. Oh, another client? They want breadth first search? So I have 2 clients, and one wants breadth first search, one wants depth first search. Okay. Yeah, I think we can get that to work. All right, so I just got off the phone. So we have our depth first search, but I have another client who's going to be using this dashboard too, and they want a breadth first search. So now I need to support both of these algorithms. So we're going to decouple this depth first search algorithm from the dashboard, and then we're going to encapsulate the depth first search algorithm behind some kind of interface, which the breadth first search algorithm can also implement, and then our dashboard can depend on that interface and support both algorithms, which is exactly what we want. So first off, let's create that interface. So I'm going to add a new folder actually. I'm going to call it available dashboard location strategies. And inside here, we're going to have an interface that we're going to use to encapsulate all of these different algorithms. The available dashboard location strategy, and each of our strategies will implement this interface. So representing what we did with our depth first search, we want to find a location and take in the start location and get a dashboard location back. So we're going to get back a dashboard location. This is still going to be optional, so we are still going to return null if we couldn't find an available location. We can just call this method find, and then all we need passed in is the start location. So you might notice that we are not defining this hash set as a parameter. And the reason we're doing that is because this is just specific to the depth first search. So we're not going to need this hash set for the breadth first search. And quite frankly, the client shouldn't really have to pass in the hash set anyways. We can manage all of that inside of our strategy class. So let's create that class. Oh, that's going to be a pretty long name. So the depth first available dashboard location strategy. I bet I could have came up with a better name, something more concise, but let's just roll with this. And it's going to implement our interface, the iAvailable dashboard location strategy. Let's implement that. And let's just move over all of our depth first search logic. So I'm going to grab all of this, and we can just cut it out actually and paste that in here. And we're actually missing a few things. So let's take care of the search locations hash set first. So to do that, I'm actually going to create a new method. So the signature is going to be pretty similar. So I'm just going to copy this and change this find method to private. So this one has all of our logic in it. And then we can add the hash set of search locations here. So add that. And then for this public find method, we can just call this find method down here, pass in the start location, and instantiate our hash set and return that value. And now we can recursively call this find method. So let's do that down here. And now we also need the width of the dashboard, the height of the dashboard, and also a way to check if there's not already an item at the dashboard location. So we could pass in all these items individually or extract some kind of other data structure for the dashboard, but I think it actually makes sense here to just pass in the dashboard as another parameter. So let's add that and then make sure we do that in our strategy as well. So now we get the dashboard, and now we can pass in the dashboard to our recursive depth first search and add that parameter here as well. And now we can call it dashboard has item. So check that. And then I'm going to move all of this logic into the dashboard. So let me cut this out, and we're going to have another method on the dashboard, and I'm going to call this is within bounds, and it's going to take in an X and a Y. So let's generate that method real quick. So is within bounds. Let's paste in that logic that I had copied. And we are within the bounds if X is greater than or equal to 0, if X is less than the width, if the Y is greater than or equal to 0, and if the Y is less than the height. And I've been saying and for all these, so let's change all of these to and. And there we go. So now if the location X and Y is not within the bounds, then we're going to return null, because the location is not valid. And finally, let's update our recursive function call down here, pass in our dashboard, and this depth first search should be complete. So now we just need our dashboard to depend on our strategy, and we can delegate all of the finding available location logic to our strategy. So let's get our strategy passed through the constructor, quite the long name, and let's throw that into a field. So now we can use this strategy. So now when we add an item, let's use our strategy to find an available location. We're going to pass in the start location, which is just the location we're trying to place an item at, and we can pass in this dashboard. And finally, we don't need this old function in here anymore, because we have our strategy. And now most importantly, before we run this, we need to pass in our strategy when we instantiate our dashboard. So the new depth first available dashboard location strategy. So if we run this, we should be delegating to that strategy. So I've hit a breakpoint where we're going to hit our strategy. So if we continue, then we used our strategy and we placed the items via a depth first search. So now if we want to support a breadth first search approach, we can have another strategy for the breadth first search algorithm. So let's add that breadth first available dashboard location strategy. Such a long name. Let's add that. Again, this is going to implement our interface. So let's do that and implement that. So for a breadth first search, we actually use a queue. So let's create one of those. So this is going to be a queue of dashboard locations. We'll call this locations to search and just instantiate that queue. And then the first location to search is going to be our start location, so we can enqueue that into the queue. And then we're also going to have to keep track of locations that we've already searched, similar to what we did for the depth first search. So let's just throw a hash set up here for dashboard locations that we've already searched. We'll call this searched locations. And of course, we're gonna have to mark the start location as already searched. So let's add that to our hash set. And now while our queue of locations to search is not empty, so the count is greater than 0, then that means we still have locations we can search for. So let's grab a location out of that queue. So we can use our locations to search queue and dequeue the first item. Now, if this location is within the bounds of the dashboard, so it is valid, so we can use is within bounds and pass in the X and Y. And if the dashboard doesn't have an item at this location, then that means this location is the winner and it is available, so we can just return it from this function and be done. But if this location is not the winner, then we want to search the surrounding locations. So same kind of thing that we did here. We want to get the surrounding locations. I could probably encapsulate this get surrounding locations logic in the actual dashboard location struct as a function, but I'll just copy and paste it for the sake of demoing. But now, same as what we did for the depth first search, let's iterate over all of these locations. So we'll call this next location. And if this location is within the bounds of the dashboard, so we'll do is within bounds again and pass in the location X and Y. And then also, if we haven't already visited this location, so for this we want to use our search locations hash set and see if the hash set doesn't contain that location. So if this is really a potential location, we want to add it to the locations to search queue. So let's enqueue that next location and then also add it to search locations. So search locations and add this location. And then finally, if we end up searching all these locations and our queue is eventually empty, then we're just going to return null because we couldn't find a location. So now let's try out our breadth first strategy. So let's pass that into our dashboard and let's try this out. And here we go. This looks good. So we placed 1 successfully and then 2 above and then 3 in the next closest location to the right. So this will probably be easier to demonstrate with more items. So let's just throw some more in here and let's put these more in the center. So let's put all of them at location 2, 2. Let me just go through and update this. And now we should really see the breadth first behavior, which we do. We're kind of going in like a circle. There might be a bug here because I do not see 6. So that's not good. We're going to come back to that in a second. Let's see if depth first works and see if we get all of these placed. So yeah, this looks like it's working. So we get all of them going depth first, but let's get back to breadth first and see if we can figure out the bug here. So if we're debugging this, I first specifically just want to look at the number 6. So I'm going to put a breakpoint here and have a condition where I want the value to be 6. So I only want to hit this when we're trying to place the number 6 because that's the one that seems to have the issue. So let's run this and all right, we hit a breakpoint and yup, this is for 6. So let's step into our strategy and I'm just going to run through this until I find something interesting. Oh, and I see the issue. So when we're creating these surrounding locations, we're using our start location every single time. We should be using the current location that we're trying to place an item at. So this was kind of because we copy and pasted this list from our depth first search. So let's change that to current location and this should all work perfectly fine. So let me get rid of these breakpoints and now we should have our breadth first search. There we go. 6 does get placed. So just to summarize what we did, first we implemented the depth first search algorithm directly within this dashboard class. So it was just nested in here. But then we got a call from the client and we had to support a depth first search as well as a breadth first search. So what we did was we leveraged the strategy pattern to encapsulate our available dashboard location strategies, so the depth first one and the breadth first one, behind this available dashboard location strategy. And then our dashboard could just depend on that interface, which means it could support both of the strategies. And as a result, both of our clients are happy and our dashboard is decoupled from these complicated algorithms. And hey, we could even support more algorithms in the future, which is pretty cool. So hopefully you can apply the strategy pattern to your own application to decouple complicated algorithms from the client and support multiple different algorithms. If you have any questions, criticisms, or concerns, be sure to leave those below in the comment section. If you enjoyed the video or are enjoying the channel, consider becoming a member. Other than that, leave a like or subscribe for more. Thank you.